Okay, the next problem wants us to write the sum using summation notation. If you look at this and you start to determine that the pattern is you're adding 6 each time, then you know it's an arithmetic sequence. And we have a explicit rule for the arithmetic sequence right off our formula sheet that we can write. The first term is -7, and the common difference is 6. And we can simplify this a little bit. If I distribute the 6, that gives me 6n. And then -6 plus -7 would be -13. So there's my rule, my explicit sequence rule. And to write it in summation notation then for the sum, what you do is you put that right here. Because you're telling, this means we're going to add up and then all of these terms of this sequence. So we need to figure out how many terms to add up. We're going to go from 1. That's the first term. If you plug in 1, you can check to make sure you get -7. All the way up to this last term. Now I don't know what term number that is right there, but that's the number that goes here. So what I'm going to have to do is I'm going to have to plug that in here. This is 53, and find out what term number that is. Add 13 to both sides. You get 66 equals 6n. Divide both sides by 6, and you get n equals 11. So that means 11 goes here. So we're adding up 11 terms of this sequence. And that's our answer for the sum using summation notation. All right, the next problem says determine whether the infinite geometric series converges. If it does, find the sum. Now the key right here is r. There's r if you look at this. I know our formula is g sub 1 times r to the n minus 1 on the formula sheet. So if you compare the exponents, they're different. One's n and one's n minus 1, or it doesn't matter what variable you use. J, they're using j here. But that's okay. It just means you're starting at a different spot. So when you plug in 1 right here, if you start writing out this, what this means is the first term, if you plug in 1, is 3/4. And if you do the second term then, the second term gives you 3/16, and so on. You're just multiplying by 1/4 each time. So really what I could do is I could write the same thing. I could do 3 times 1/4 to the n minus 1, and then instead of starting it at 1, start it at 2, n equals 2. This means the exact same thing. If you start at 2, that will give you the first term of 3/4, which is what we want to be our first term. So these are identical, exactly identical. So there's different ways to write it basically. But what we're asked is whether or not it converges. And it does converge because this value right here is between -1 and 1. And that's on the formula sheet right here. It says that infinite geometric series converge if the absolute value of r is less than 1, which basically means r is between -1 and 1. And then it says we can use this formula right here to find the sum. So that's what we're going to do. And it makes sense because we're multiplying by a number that's making each successive term smaller. So what that looks like, if we were to graph that, is all these points are going, to 0. So we could add all of them up, and that's going to give us an actual value. And that's what this formula does for us. So to plug this in, the first term we know is 3/4 divided by 1 minus r is 1/4. So we can simplify this. This is 3/4 over, I'll make this 4/4, so it'll be divided by 3/4, which obviously is just 1, right? Multiply by the reciprocal instead, for example, and you get 1. So we know the answer is 1. What we can do is we can actually do this in the calculator as well. If you plug this in and do alpha window, and you do summation notation, and you go from, I'm going to use x instead of j, but I'm going to go from 1 to, just do like 25 and see what happens once, of 3 times 1/4. Oops. Let me do alpha y equals here and do the fraction to make this neater. This is 1/4, and then I can raise this whole number to the x power, which is what they want. And it looks like I'm in parametric mode. I'm sorry about that. Let me change this back into function mode. And I have t's here instead of x's because I was in parametric mode, but it still worked. The answer is 1. And I could add up fewer terms. So if I grab this again and add up fewer, the calculator's rounding obviously because it's so close to 1. But if I add up fewer terms, like maybe 5 terms, it's still going to be a number close to 1 because let me delete that. Let me do alpha. Let me actually do math decimal here. All right, so hit enter. and then hit math fraction, or math decimal. This should work. So it's really close, you can see. You don't need to add up many terms in order to get really close to the infinite sum. So you can really do it in the calculator, but I will check for work as well. And the reason why is because this thing goes down pretty quickly, so you don't need to add up that many before you get these values over here are basically 0. You know, there's nothing really to add at that point. So it doesn't take much to do it in the calculator as well. Okay, the next problem says a certain small business has 35 employees, 21 women, 14 men. How many different employee representative committees are there if the committee must consist of 2 women, 2 men? All right, so we're choosing 2 women, and we're also choosing 2 men from 14. So we would just do this. Order doesn't matter here because, you know, it doesn't matter whether we have, you know, Cindy or Jessica or vice versa, as long as we just have 2 women. So order doesn't matter, and we do 21 C2 times 14 C2, and that gives us 19,110. Okay, the next problem wants us to use this quadratic in this point to find the slope of the graph at this point. Now, I'm going to do the derivative just using the power rule, right, where you multiply the exponent down and lower the exponent. So this would be the derivative right here. Now, if we plug in 2, that gives us the slope at that point. So that'd be 4 times 2, which is 8, minus 7, which is 1. So we know the slope at 2 has got to be 1. So this is a parabola. It wants the equation of that tangent line at the point. So we know the slope is 1, so we can do y equals mx plus b, where we plug in 1 for the slope. And we don't know the y-intercept yet, but we can find the y-intercept if we use the ordered pair at that point. So I know x is 2, so I'm going to plug in 2. And I'm going to find the corresponding y-coordinate by plugging in 2 here, in which case that gives me -3. So this is the point 2, -3. So I can plug in -3 here, and I can solve this then. Subtract 2 from both sides, you get -5. So b equals -5. That makes the equation then y equals 1x minus 5. So this line at 2, -1, 2, 3 touches right there and has a slope of 1. So there's our tangent line. It wants us to then sketch a graph of the curve near the point. Obviously the parabola must look something like this. This is just a rough sketch, but it's got to look something like that. And you could actually find the vertex pretty easily if you did x equals -b over 2a. That would give you the x-coordinate for the vertex and give you more information about what this sketch actually looks like. But we've got the equation for the tangent line. Here's the tangent line right there. And the slope of this line is 1 at that point. Okay, one more power rule 1. If you want to do the derivative of this function, it would be -2x. And then at 2, you just plug in 2. So the derivative at 2 gives you -4. So it's 2, -4. So our answer is actually -4 though. That's the derivative at that point. Therefore, that's the slope of the tangent line at x equals 2. Okay, the next problem wants to find definite integral by computing area. So let's quickly look at a graph of this function. It has a y-intercept of 3 and it has a slope of 1, so it goes like this. And we want from 1 to 4. So 1, 2, 3, 4. So we're looking at this trapezoid right here. And to find the area of a trapezoid, we have a formula for that. It's 1/2 height times base 1 plus base 2. So it's 1/2. The height of this thing is 1, 2, 3. And then we need to use both of these bases here. If I plug 1 into this function, this is the order pair 1, 4. And if I plug 4 into this is the order pair 4, 7. So these bases have heights of 4 and 7 respectively. So that's what we would do to find the area, which is 16.5. Now we can double check that with the calculator as well. If we do alpha window and do function integral, which is the 4th one, and just type this in. 1 to 4 of x plus 3 in terms of x gives me 16.5. Okay, the next problem right here gives me this equation. Now, this you might recognize. You can graph it in your calculator if you want. If you do y equals square root of 4 minus x squared, you'll get this right here, which is half of a circle. It goes like this with a radius of 2. Now, you could also figure this out without, because if you square both sides, you get y squared equals 4 minus x squared. Add x squared to both sides, you get x squared equals y squared equals 4, which is an equation for a circle centered at the origin with radius 2. if you remember. So what they're looking for, now the reason it's just the top part of the circle is because if you were to solve this back for y, you'd have to do plus or minus when you took the square root. Since we're only dealing with the plus, not the minus, it's just the top part of the circle, not the bottom part of the circle. So, you know, there's different ways to look at it, but you could graph this, like I said, in your calculator, you'll get this top part. Now, what's the area of this right here? I would just do pi r squared and then take 1/2 of that. So it's 1/2 pi times the radius, which is 2 squared, in which case you have 4 divided by 2 is 2, so the answer is just 2 pi. And once again, you can do that on the calculator if you just type it in with function integral, and you should get 2 pi. And that's exactly what you get. Okay, the next problem wants to find the limit as x approaches 2. Now, this is just a cubic function, and it's defined everywhere. It's continuous, so we can just substitute, plug in 2. And if you plug in 2 to this function, you get 7. Therefore, you know, at 2, this thing's at a y value of 7 from both sides. Therefore, the limit as we approach 2 of this function is 7. All right, the next problem says, explain why you cannot use substitution to find the limit, which we can't in this case because we'd get an undefined value in the bottom. -3 squared is 9, minus 9 is 0. You can't divide by 0. So that's why, but for part B, you can do it algebraically if you factor, because the top factors into x plus 3, x plus 4, and the bottom is the difference of 2 squares, which factors into x minus 3, x plus 3, in which case these factors would cancel and I'd get x plus 4 over x minus 3, and then I can use substitution. So now I can plug in -3, in which case I get 1 over -6. So there is the actual limit, and if you want to know what that looks like, we could go to the calculator and plug this in. So here's the graph. If we want to know what happens at -3, it's actually, it doesn't look like it, but it's undefined. If you do second calculate value at -3, you'll get the undefined value. But if you look at your table, if you go to second table set, and you start your table at -3 and go by a small amount like 0.01 or something, and then you look at your table, you can see right around -3, you're at like about 0.166-ish, which is exactly what this is. So you can kind of see, you can verify this with the calculator if you go to your table and look right around that point, because what's happening right around that point is the limit is approaching the same value, -1/6 right there, from both the left and the right. So that is still a limit, even though the actual function is not defined at -3. Okay, the next problem is the same thing. If we're going to do this with algebra, what we need to do is first factor the top. It factors into x minus 2, x plus 2, and the bottom would be x plus 2. So we could cancel that. We know that's a whole then, once again, and now we can substitute in the -2. If we substitute in the -2, we get -4. So we can check that on the calculator, and what we see when we look at this graph is a line. In fact, what line we see is this line right here. It's just this thing equals x minus 2. The only place it's different is at -2. There's an undefined spot, and I can show you that in the calculator. At -2, it's undefined. Second calculate value at -2 is undefined. There's a hole there. I can show you the table as well. If I set it start at -2 and go by ones, then when I look at that table, what you're going to see is it's a regular line. There's just an error. There's just an undefined spot at -2. Okay, the next question wants us to find the limit as x approaches 2 from the left. As we approach 2 from the left, the limit is 3. As we approach 2 from the right, the limit is 1. And as we approach 2 overall, the limit does not exist because it's reaching different values from the left and the right. Okay, the next problem is the same thing, only it wants us to generate the graph ourselves. So let's pull up the calculator and plug that. And now we can see that there is a vertical asymptote at 3. And that you can get off the formula sheet as well. But this thing approaches -infinity as you approach 3 from the left. And if you recall from the formula sheet, vertical asymptotes occur at zeros of the denominator, so we should know that that's there without even looking at the graph.